Yeah, so good morning, everyone. I hope you enjoyed the conference so far. Yes, I did 9 talks already, but I'm still nervous. So it doesn't disappear. So, all right. Today I will talk about taming reactive Node.js, basically. So we'll dive into the stream-oriented architectures. And I will show you how Nest framework can greatly help you with implementation of such streams-driven systems. Before we move to the main topic, I would like to quickly introduce myself real quick because we don't have too much time. My name is Kamil. I'm a co-founder of Trillion.io, the next level software consulting company. And basically, I'm a software engineer primarily focused on the web-related things. You can find me on Twitter using this highlighted red Twitter handle and obviously on the GitHub. Beyond regular day-to-day work, I'm giving the value back to the community as an open source contributor. I'm the creator of NestJS, which is basically the fastest rising and the most popular framework for Node.js in 2018. In the last year, we have noted 300% growth in the popularity in number of GitHub stars, leaving behind any other existing famous library like Express, Koa, Happy.js, all of them, which is pretty amazing. And regarding Nest, maybe let's start with the question. Who has heard about Nest already? Please raise your hand. Woo! All right. 50%, maybe 20%, 25%. So just to ensure that everyone is on the same page, it's a framework for server-side applications, writing server-side applications on top of Node.js. It's written entirely in TypeScript, but remains the compatibility with pure vanilla JavaScript. So if you prefer JS, no worries, you can use it. Also, it's heavily inspired by Angular, but it doesn't mean that you necessarily have to use Angular. You can use Vue, you can use React. It's up to you. All right, let's firstly ask ourselves a question. What is a stream-oriented architecture? So stream-oriented architecture is basically just a fancy name over secure REST pattern, so common query responsibility segregation, in which you have some kind of domain comments, domain queries, domain events, and all of them occur over time. So all these elements form streams. What is a stream? So this is a simple stream on the slide. It's a kind of timeline, like one line. And you can see a number of events on the timeline. So every circle is a kind of event. And they occur randomly. Sometimes you cannot predict when. So it's a kind of data set in which you have values asynchronously instead of synchronously. It's like an array, but you don't have every value in place. You get them over time. You have to wait like 1 minute break even, 2 minutes break even, and so on and so on. So normally, you more or less expect that code that you write is going to execute incrementally, like complete incrementally. In this model, on the other hand, we have to slightly switch our mindset. We have to think about, like, start thinking reactively. Once we have an event, we have to process it. Once we have a comment, we have to react. We have to execute some business logic associated with this set and event or comment. What are the, maybe let's start with advantages. What are the advantages of such stream-driven architecture? So surely it leads to a more readable code. We have handlers that have one responsibility. Every change in our system has to be preceded by some kind of event occurrence, actually common occurrence. So it's a predictability as well. Everything has its own place. Additionally, your application is loosely coupled, which means that you can easily avoid this domino effect. Once you change something, it's not going to break the rest of the application. And your elements are kind of self-describable, usually have very descriptive names, so you can look at the names of the events to have a kind of high, high overview of the architecture, what's going on right now in your system, high-level ideas, and so on and so on. Let's real quick jump to the disadvantages right now. So I would say that there is one huge disadvantage, which boils down to a few other ones, smaller ones, but generally it's called complexity. So lots of boilerplate code has to be written down to achieve even simple operations. For instance, a great example, Redux. Lots of people, like everybody who is writing front-end applications nowadays, is familiar with Redux as a state management solution, right? And Redux is kind of inspired by CQRS, by event-driven architectures. And we know that Redux gives you an excellent advantages, like you have a DevTools, you have a predictability, you have a one-way data flow. But the problem is, if you want to increase the value, for example, which normally should be like write one line of code with ++ variable or variable ++, You have to create an action. You have to create a reducer. We have to create a selector. Lots of stuff. So that's the problem. Redux is great, but you have a lot of overhead. And this is what I'm going to show today, but in case like in server-side applications. So talking about the theory is always a good background for our knowledge, but I'm going to show you an example how to transform a services layered architecture, so this common approach nowadays, to a typical stream-oriented one. We'll face some challenges, we'll contrast both solutions, and so on. So what we are going to do, let's assume that we are a kind of game in which heroes have to slay dragons. Right? You have to slay as many dragons as possible, and the hero will then get points of experience, may get an item, may get some coins, and stuff like that. And we obviously do not have enough time to cover every business functionality, so we'll only like take care of this one single endpoint, assuming that we are creating REST API. And this endpoint takes such body of the request, only Dragon ID. So the layered architecture. Maybe let's briefly look at the design, like diagram. We have a controller, which basically is our transfer layer, which takes requests and responds answers to the users. We got a service layer, which holds every business functionalities, and we have a data access abstraction over our database, over our event log, or something like that. And let's move to the code right now. So in Nest, you can create endpoints in the declarative way. So basically, you can use a patch, post, get, and stuff like that over on the methods itself. In order to extract input variables, you are using decorators as well. So here we are using param to get the hero ID from the endpoint, and we are using Dragon ID to extract the Dragon ID from the body of the request. And then we are consequently executing associated method, corresponding method in the service layer. Service, on the other hand, holds the business logic, business functionalities. So assuming that we have this hero service, which has a one method, slay dragon, this is the body of the method. We don't have enough time to just like explain everything in detail. So just to give you like high-level view, we have to fetch these entities, which is an asynchronous operation from the database. Once we have hero and the dragon, our business functionality is to increase points of experience and set a status of the dragon to false, because dragon, like, we just killed the dragon, so it's not alive anymore. It's pretty simple, 2 lines of code. And then we obviously have to save these operations to the database using our repositories, or update our entities to reflect our changes in the, let's say, SQL databases. And in best case, it should be wrapped in the transaction, because we want to update hero and the dragon, never one of them only. All right, we have our baseline. We have our game created already. The problem is that it doesn't have many functionalities in place, so we started to introduce more features. One of these, artifacts. So every time when hero kills the dragon, it has an opportunity to get an item, like a sword or like a shield to protect yourself. So the business logic, business functionality is pretty simple here. Every time when you kill the dragon, which level is higher than 3, you are getting random item. Again, like 4 lines of code, nothing else. Get random item, asynchronous operation, concat the array of items, and that's it. Cool. We have another feature. Now let's think about currency. We need a way to buy drinks, like buy food, buy the hero, and so on and so on. We need some kind of currency. So we have introduced coins. What's the business functionality, business requirement here? Every time, so there is a one way, every time when hero kills the dragon, there is 30% probability to get random number of coins. Quite simple. The second thing, every time when hero gets an item, there is, again, 30% of probability to get an item, right? So we have 2 different ways to get an item, to get coins. And actually, that's it. That's our game. Finished. So that was our layered architecture, one single endpoint. Now we are going to move from the layered architecture to the stream-oriented one. So taking a step back to our slay dragon method from the controller, from the hero's controller. We've been calling service method. But right now, in stream-oriented architecture, in CQRS, we don't have services layer anymore. Instead, We have commands, we have queries, we have events. So what we have to do, we have to execute a command. What is a command? So in the Redux, you have an action. Action is both command and event at once. While in a typical secure REST architecture, you have separately commands and events. Command is a kind of request for a change. So I'm requesting that the dragon has been killed by the hero, has to be killed by the hero. It's a pretty simple class which has two properties, hero ID, dragon ID, that's it. And the command bus is provided out of the box by the NestJS secure REST package. So you don't have to worry about an internal implementation. The only thing that you have to worry about is that it's a kind of stream. All right, we have dispatched a command. Now we have to process it. And how to process the command? We have to create a command handler. In order to create a command handler in a declarative way, we again are using decorators. So we have a class which implements an interface, iCommand handler, and we have a command handler decorator. But the most crucial thing here is that we have to put the type of the command here. So as you can see, you can have automatically bind your command with an expected command handler by the framework. All right, and every command handler has an execute method. This execute method takes the command as an input parameter. What we have to do? Similarly, as in the services layer, we have to extract the hero ID and the dragon ID. Then we have to get these entities from the database, right? It's just copy-pasted. Nothing has changed here. Then we have to perform our business logic. Increase points of experience, set dragon status to is alive to false. That's it. We are done. However, what we have to do as well, we have to dispatch an event. We have to notify the rest of the application that something has changed, right? We cannot just change these values. We have to notify the rest of the application that something has happened, and we have to use events for that. So what we have done right now, we have created a method, which is a slate dragon of the hero entity, and I will show this method later on. What is the most important here is a hero commit. So every time when you change something, you have to commit your changes similarly as in the Git repository. So this is the slate dragon method that I talk about. We have this typical business logic here. This experience, dragon is alive, but the most important part is this applies. So now we are dispatching an event, and we have a domain event, which is hero slate dragon event. This class has only properties: hero ID, dragon level, experience points. It doesn't have methods. It doesn't have getters, setters. So the implementation is useless. The only thing that we have to be aware of is that it has these properties, like a box for values, as a kind of domain wrapper for these properties. All right, I know that it might get confusing. So let's look at the high-level architecture overview right now. Again, we have a command. Every command is processed by the appropriate command handler. We don't have services anymore. Every command handler is using domain models or is dispatching events directly. And now the missing piece of our architecture, every event has to be handled by the event handler. What is an event handler? Almost the same thing as in the command handlers. But the only difference is that we have to implement a different interface, which is event handler, and we have to use a different decorator, which is events handler. And again, the most important part, we have to pass the type here. So framework will take care of the whole heavy lifting underneath. You don't have to worry about the association between commands and command handlers, between events and events handler. We are going to do it automatically out of the box, which is super awesome. And every event has to handle, every event handler has to handle event. It gets an input. This input is this particular event. And as you can see, there is a comment here, persistent logic. So what you can do, you can log your events, you can save those events, you can basically do whatever you want to. But since we want to reflect our services architecture, we would have to copy-paste this piece of the code and put it here. So we are extracting hero ID, dragon ID, experience points, and we have to update the database. But there is a problem. The problem is that it's very tough, very difficult to manage distributed transactions. So if you are using secure REST pattern together with a relational database like SQL, without even store, without even sourcing, it's very tough to handle distributed transactions, which means that it gives you even more boilerplate code, even more overhead. So instead of using this approach, we'll rather sometimes use like typical event store. And we have a talk about event sourcing. So this is basically it, right? Store for our events in the correct order. So what you can do, you can put this single line of code in the event handler, and it's gonna save your event to the store. Obviously, you don't have to do it manually. You can just subscribe to the event store and automatically save every event instead of creating event handler for all of them. All right, it was pretty simple. We have our application, our hero game in the stream-oriented architecture finished. It's working, right? We have a command, we have an event, we are updating entities, we are performing business logic, super awesome. Now we have to introduce these features, these missing features, artifacts and coins. Let's have a look at our architecture once again. We have this command handler, events, event handler. There is a missing piece here. And the missing piece is a Saga. Saga subscribes to incoming events and can dispatch commands. Can. It doesn't have to, but can. So if you're familiar with, for example, Angular, Angular has NGRX package. Saga is like an effect. If you are familiar with React, there is a Redux Saga, which basically implements a kind of side effects package, like features for you in this whole Redux world. All right, let's move to the artifacts. How to implement artifacts in RxJS way, in the reactive way. So that's the Saga. Saga is a kind of property. Actually, it's a property which is equal to function. So it's a function which has a Saga decorator on top of it. It's a function which takes this event stream. So you have to think about it like this timeline that I've shown you. Like events can occur over time. And since we have this stream, we have to do a few things. First of all, to recall everybody, we have to drop an item every time when the hero slays the dragon, which level is at least 3. So what we have to do? We have to filter event stream by event type, which is hero slay dragon event, right? Very declarative way. We have to filter this event based on the dragon level because we are not interested in any other dragons. And if that's the case, I have to map this event to the appropriate comment. So this drop item feature is done in this way. We have items. Now let's move to the coins part. So coins is even more simple. Like think about two different streams. We have a stream of hero slay dragon events, and we have a stream of hero find item events. What we have to do? We have a merge operator from RxJS. We are taking these two streams and we combine them together. So then we can simply take either of these, hero slay dragon event or hero found item event, and merge it based on the probability, which is obviously math random, and we can merge map it to a nested stream. It might be an empty, so we are not gonna dispatch anything, or drop coins command. And obviously, we then have to create an appropriate command handler for our drop coins command, and so on and so on. So again, just to give you a short high-level view, we have a command. Then we have a command handler that hero slays the dragon. We are dispatching an event. In our case, just one single event. At the diagram, you can see multiple events because you don't have to necessarily dispatch only one single event. You can dispatch multiple events. But we are dispatching only one, and we don't need anything else. And then we are processing our event inside an event handler. However, our sagas, two sagas, subscribe to the event's emission, and based on some conditions can lead to dispatching another command, drop coins command or drop item command. So it's a highly scalable solution, very extensible, really like you can add more things only to the saga react on events instead of putting more imperative code inside the services, because in the services layer, you mostly have like 20 or 30 or even 40. It's growing over time. It's more and more complicated business functionalities. Here, you can split them into different pieces of the architecture, which makes it incredibly scalable over time. But as I said, it brings a lot of overhead, a lot of boilerplate. As you can see, common handlers, common event handlers, events, and also sagas, pretty much the same as in the Redux, right? Just increment the value, one line, no. Action, reducer, state, and so on and so on. All right. Lastly, I would like to say that Nest, so the Nest framework, is open sourced, meaning that we are totally driven by the community. And therefore, I encourage everyone here, to join this little revolution, to contribute, to help us growing, to make it even better framework every single day. Also, there are a couple of companies and even more than 100 people already who decided to donate, support us with the donation, which is pretty amazing. A big thank you to all of them. And if you are looking for consulting, like if you are struggling with a migration of your Node application to Nest, or you're looking for expertise consulting in Angular and architectural things around, just visit the website, send us a message, and we'll talk. So thank you.